All right, Matt 3. Real quick for the circle unit test review, I'm going to go over some of those things with you. In circle T, it says with the angle measure, with measure of angle STU being 134, find the measure of minor arc SU. So they're wanting to know what this is. All right, now remember, central angle, something on my paper, central angle is equal to the arc made. Okay, so if the central angle is 134, then the arc it makes, which is SU, is also 134. All right, in circle L with this measure of arc KM being 66, find the measure of KLM. Okay, so going back to this, central angle and arc are equal. If the arc is 66, that means the measure of angle KLM, which is this guy, is also 66. Very easy problems there. All right. Inscribed angle. And the reason why it's inscribed, vertex, on the circumference. Okay, so when the vertex goes from the middle to the circumference, it's a little different. Remember the arc, it's 2 times inscribed angle is equal to the arc. Okay, so it says HLK, which is the inscribed angle, is 33 degrees. What is the measure of HK? All right, so that means it's 2 times 33, inscribed angle is 33, equals the arc. So the arc is equal to 66 degrees. All right. All right, in circle F with the measure of the minor arc being 138, find the measure of EHJ, or EHG, excuse me. EG is 138. Now, you look for this. Now remember the arc divided by 2 is the inscribed angle. It's just the converse of the other theorem. So 138 divided by 2 will be 70, about what, 69 degrees. So it's just the angle is half the the angle is half the arc it makes. All right, so in circle J with measure HLK, that's 39. All right, you don't know what, you're trying to find the middle, or excuse me, the central angle of HJK. All right, so now what we do know is if this is inscribed, if that's an inscribed angle, then this arc is 2 times that, so it's 2 times 39. That's 78 degrees. All right, so 2 times this arc is twice the angle. So we know that this arc here is 78 degrees. Now, remember the central angle is going to be equal to the arc that it's made, because the central angle and the inscribed angle makes the same arc, KH. So, so you're trying to find the measure of HJK. Well, since the angle and the central angle and the arc are the same, 78 degrees. All right. Very theorem heavy. So as far as my note card, I would make sure I have some theorems to help you. All right. MPO is 54. That's inscribed. So all right, so now, so let's see. It says the arc is this expression, 7x equals 49, or 7x plus 49, excuse me. And then the inscribed angle is 54. Okay, so 2 times 54 is equal to 7x plus 49. Now, make sure that's a 4 there. Now, I'd do this at Desmos if it was me. Let's see. Let me pull up Desmos. All right, and then, so 2 times 54. Guys, don't forget, you will have to put y equals there, 2 times 54. All right, and then y equals, okay, make sure I got this in right. Y equals 7. It is 54. Okay, so we can have decimals here. Okay, so that's why I was wondering, because we got a decimal here. So if you see this, just be around your extra nearest tenth. Just keep that in mind that you could have a decimal. Okay, so you solve for x. So we got x is approximately 8.4. I'm just solving for x, so that would be your answer. Okay. Now going to angles and circles. Now notice vertex inside the circle. So now let's think about this just a minute. The vertex is inside. That's what really matters, where your vertex is. Vertex is inside. It's arc 1 plus arc 2 divided by 2 is equal to the inside angle. All right, so now that being said, I've got 2 arcs here, measure of ME. ME is 105. DP, which is this guy right here, is 119. And you're trying to find MHE, which is this angle right here. Now remember, of course, which it don't really matter. These 2 angles here would be congruent, but it really doesn't matter about that. So now, we don't matter which one. We'll call this arc 1. We'll call this arc 2. It doesn't really matter which one it is because you're adding. So I'll start my division bar. 105. Oh yeah, by the way, we need to make sure that, well, never mind, that's okay. So 105 plus 119 divided by 2 is 112. So the measurement of angle MHE is equal to 112. All right, so as far as the representation, it was arc ME plus arc DP divided by 2 is equal to angle MHE. All right, so that would be how you'd show it with the given sides. All right. Now, this is an outside angle, so outside vertex. So now, if the vertex is outside, it's always big arc minus small arc divided by 2 is equal to the outside angle. Now, if we set this up, you guys really, I think it'd help you. I like to see this on the test. It's going to be arc QD minus arc XJ. Because these arcs out here is irrelevant. You don't care about those as far as this goes. And then divided by 2, that's part of your, is equal to so that's really, I mean, guys, that's, I mean, you don't have to really input measure there, angle V. So now, So it's the big arc 150 minus the small arc, which is 50, divided by 2. Well, if you put that in a calculator, that's going to be 100 divided by 2, which is 50. Guys, I'm trying to keep as much algebraic stuff out here as I can. That way, doesn't make the questions just quite as hard to set up. Okay. Now it says IB is a tangent to circle O at point I. So what this is saying is they touch at that point right there. Find the measure of AIB. AIB. Okay, so we're looking for this guy right here. If IKA, which is this big major arc here, because it's greater than 2, then it's greater than 180, right? Now, guys, regardless if, this is still an inscribed angle because the vertex of the angle is on the circumference. So it's 2 times inscribed angle equal to the arc so now that's 2 times angle AIB is equal to the arc is 252. So now if you think about it, to get AIB by itself, you're just going to divide by 2. I just sat here and wrote that wrong. That's 252. All right. So now divide by 2. So the measure of AIB's by itself is equal to 126. Now you could have done. The arc divided by 2 is equal to the angle, right? AIB. You could have done 252 divided by 2, and that would have gave you 126. Either way you want to do it, don't really matter. Just know what your what your formula is. All right. Sleepy. Okay. Now looking at the next one, this is a central angle again. Going back to central angle, it says the measure of arc GS is 58 degrees. GS is 58. The measurement of GXS is 93. GXS is 93. And then find the measure of LZ, which is this guy right here. So this is what we're looking for. We're looking for this part of the arc right here. All right, so let's think about this. We know that arc LZ plus arc GS divided by 2 is angle GXS. So GXS, which is this angle right here. All right, now if we plug in what we know, I'm gonna put, instead of LZ here, I'm gonna put an X here. X plus GS divided by 2 is equal to 93. Now, you can solve this by hand if you want to. That's up to you. But if you want Desmos to do it for you, that's fine as well. So Y equals division bar X plus 58 divided by 2. And then Y equals 93. Oop, didn't mean to do that. 93. All right, it's saying that the measure of X measure of X is 128. All right, guys, as far as these angles go, I like to see all of this right here, but you would at least have to show me this so I'll know exactly how you got it. Now these are the ones I want to see the This is the one I'd like to see. No, this is still angles here. Never mind. Okay, so we're looking for angle. So it says if the measure of arc PF, which is your big angle, or big arc, excuse me, is 98, and the measure of A is 34, then what is this little measurement right here? KQ, okay? So that being said, now it's if you got an outside vertex, it's big arc minus small arc divided by 2 equals outside angle. Okay. All right, big arc. Now guys, for the small here, what I'm going to do, so it's going to be PF minus QK is equal to, divided by 2, is equal to angle A. All right, so now PF is 98. KQ we don't know, it's just going to be X divided by 2 is equal to 34. All right. Now, once again, you could use Desmos. I don't really care. Make sure you do set the. I need to see how you got it. Okay, so I like to see all of this, but at least this much right here. The segments is where you got to give me what you're going to be multiplying together. Okay, so y equals division bar 98 minus x. Ah, shoot. Let me see right here. 98 minus x divided by 2. Y equals 34. Okay, so it says the measure of x is 30. X is 30. So that means since we mark x as KQ, the measure of arc KQ is 30 degrees. All right, and that makes sense because if you want to check it, big arc minus small arc, which is KQ, divided by 2 should give you that inside angle, or outside angle, excuse me. Well, that's 68 divided by 2, which is 34. So that makes it tell me that is right. Okay. All right. SU is tangent to circle O at point P. PW is a circle's diameter. Okay. Find the measure of SPW. So what that means is if you got a diameter here, okay, that means that this arc is 180. Okay, because remember a diameter makes 2 semicircles. This is 180. This is 180. Okay, and it is tangent. Okay, so notice where your vertex is. It's inscribed. It's on the circumference. Now, PW is the circle's diameter. Find SPW. Okay, so SPW is this angle right here. Well, that one's pretty easy. I mean, if it's inscribed angle and you've got the arc, it's just the arc divided by 2 is inscribed angle. Well, that would be arc WP divided by 2 equals angle SPW. So that would be 180 divided by 2. It's 90. Okay. So 90 degrees. All right. See how long our video is getting. 19. That's not bad. All right. So now we're going, given the circle below with the chords KL, MN, find the length of KO. Okay. Now, remember guys, in this case, you've got this chord MN, you got this chord KL that intersects at point O. So this is one you're going to have to show the segment. You're going to have to show how you set up the segment statement. So if I'm looking at this, I'll just start with this guy here first. MO times NO. So MO times NO is equal to KO times LO. So make sure you know how to do this, all right? If you got intersecting chords, it's just, it's one piece times the other piece of the same chord. MO times NO equals one piece times the other piece of the other chord. That's all it's very, very simple. So MO is 23, NO is 41. KO we don't know, so we're just gonna call it X. And then LO is 34. Well, that's, I would just put that in Desmos. I mean, as long as you can. You have to show all this for the segments, remember, so don't forget that. So now let's see what this will look like on. So Y equals 23 times 41. And then Y equals X times 34. All right, just zoom out. There we go, right there. All right. Now we can get decimals here. Okay. Just make sure you got it set up right. 23 times 41. X times 34. Make sure that's in Desmos, and that looks good to me. So we're going to round to the nearest tenth. So X is equal to 27.7. All right. All right, on to the next problem. Now, these are two secants, right? Secant. All right, now, secant. That's outside times whole. Equals out times whole. Out means outside. So starting with this guy here, outside is FG. Remember, you gotta show all this. FG. Let me erase that right there. That way, you'll be able to see it. FG plus, the whole thing is FG plus GH equals this guy. The outside is FE. The whole thing is FE plus the inside, which is ED. Okay, so FG, let's see. 7 times, remember it's going to go in two places. The outside 7, and the whole thing is 7 plus 9. Equals FE, which is 8, times now I'm just going to call this X, the ED part. All right, so now, I don't care from here if you put it in Desmos. I mean, that's as long as you can show me this right here. You'll have this like on a note card or something. But you have to show me this. Must show this. All right, now, all right, so let's do Y equals. And honestly, guys, I wouldn't take no chance. I'd put it in there just like I see it. I wouldn't take any chances because if you got the calculator to use, you might as well use it to your advantage. So there's one side equal. Oh crap! Didn't mean to do that. Y equals 8. Forgot to close my parenthesis here. That's my fault. All right. So now just I'm gonna go back to home here. Zoom out. X is 6. All right. Find the length of DE, which DE was, if you notice here, guys, DE, we marked it as X, so DE is 6. Okay, so you don't have to worry about plugging it back in on that one. All right. All right, so guys, what we have here, we have a secant, touches in 2 spots. We got a tangent here. And now that formula there is tangent squared equals out times whole. Because you got a secant on this side. Okay, so now if you do that, that's I8 squared equals IJ times all right, guys, so going back, now if we plug this in, that's 23 squared equals 13 times. Now, we don't know what KJ is, so we'll mark it as X. I like the way they do this because they mark what's missing as X. All right. Now, so you are trying to find the length of KJ. All right. So now, let's go ahead and put this in Desmos. All right, y equals 13 times. All right, this may be a big number, so 23 squared is a pretty big number. All right, so we're getting an X value of 27.7. 27.7. All right, so that would be, this would be what was required. All right. It says, given the circle with secants PQR and TSR, PQR, TSR, SR is 51. So we know this is 51. TS is 33. QR is 53. Okay, this QR. Okay, I thought this would be the whole thing. QR is 53. You're trying to find the measurement of PQ, which is this little piece here. All right, so that's going to be out whole times whole equals out times whole. All right, so now that's going to be, if we start here, RS times RS plus ST equals RQ times RQ plus QP. All right, plug in what we know. That'd be 51 times 51 plus 33 equals 53 plus. Okay. All right, now just put that in Desmos. 51 times 51 plus 33. And then I'm just going to replace these. 53 and 53. All right. So this is going to be 27. So 27.8. That's the nearest tenth. All right.
What?
You gotta put that in the desk.
Okay, so with this next problem, you have a tangent line and a secant line. So with that line combination, it's going to be tangent squared equals all right, so it says RS is 5, US is 10. So the whole thing is 10. And then all right, so the tangent squared, so it's going to be RS squared equals ST times ST plus TU. All right, so the measure of RS is 5. ST, we do not know what that is. That's going to be X. And then from S all the way to U is actually 10. So the whole thing is 10. Okay, so that'd be
I'm about to break it.
all right. So the answer would be 2.5. Guys, I'm getting ready to go over the circle part of the test. So if you didn't understand what was going on Friday, this is what this is.
Oh, I don't do that.
It says determine the equation of the circle graph below. First off, you need to find your center. All right, so there's my center. My center is 5, negative 3. All right, so that part. All right, so that's going to be x minus 5 squared.
What problem do you want?
Now, 1, 2, 3, 4, 5. My radius is 5. All right, so that gives me an equation: x minus 5 squared plus y plus 3 squared equals 25. Okay, this next problem, you're given a graph. You're given the center of your circle. You got to determine the equation. Now, looking at my center already, I can go ahead and establish that that equation is going to be x minus 6 plus y plus 3 squared. Now, all I got to do, all I got to do now is find my radius, and we're going to find that by doing Pythagorean theorem in a coordinate plane. So if I go make a right triangle from the center to that point on my circle, that makes a right triangle. Okay. This is 2 units long. This one is 3 units long. All right. Then all you're doing here is finding the hypotenuse, which is going to be your radius. So 3 squared plus 2 squared equals radius squared.
Yeah.
All right. And then so bringing this down here, 9 plus 4 is 13 equals r squared. Now, if this is r squared, so if I'm putting my radius here, that'll be the square root of 13. Now, so finishing up, x minus 6 squared plus y plus 3 squared. Now, if I take the square, if something's got the square root on top and I take the square of it, it just knocks that off. So the equation of that circle is x minus 6, y plus 3 equals 13. All right, find the center and the radius of the circle represented by the equation below. We know that's my h value, that's my k value, and your center is the opposite of h, opposite of k. So if my h is positive 4, it's going to be negative 4. If my k is positive 11, it's negative 11. There's my center. Okay, and then this is this is r squared. All right. So if I need the radius, if I got r squared is equal to 81, to get the radius, I just take the square root of both sides. My radius is 9. All right. All right, this is general form of a circle. You're trying to find the radius and the center. All right, so you're going to type the whole thing in one line of Desmos. This is actually the only one where you put the whole thing in Desmos. Okay, it looks like my center here is going to be negative 7, positive 7. Okay, so I got my center from Desmos. All right. And then counting over, my radius is from the center 1, 2, 3, 4, 5 units. So my radius is 5. So that's going to be x plus 7 squared plus y minus 7 squared equals 25. All right, and if you wanted to, you could double check that. You could put that in Desmos. And that circle matches perfectly, so that is correct. So my center was negative 7, 7. and my radius is 5. Determine the equation of a circle with radius of 9 and a center of 6, -9. So I know it's going to be x. Opposite of that would be -6 plus. Opposite of -9 would be +9 equals the radius squared. Okay, so all I got to do here is square my radius. So x minus 6 squared plus be 81. That's your answer. Okay, so all we need for this circle is, you got your center will be x plus 8 squared, because opposite of that, plus y plus 8 squared, which is the opposite of that coordinate. And all you need now is the radius, which is the radius squared. All right. Now, using this, you could use the radius is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. And then that's going to be r equals -13 Alright, and then that's going to be minus a negative becomes positive. -5 squared plus -20 plus 8 is 12. And then that's going to be 144 and 25. Alright, now, so the radius, that's actually a perfect square. It's 13. So for the equation, remember it's r squared. So if I square both sides, the number goes here is 169. All right. I think that's it.